All right, this video deals with transformation of functions. So we're going to take those parent functions that we learned the last few classes and now move them around the graph. So in our notes today, we're going to be graphing the parent function and then figuring out how the new function moved. So I've got this little chart that I've already got filled out, so you'll need to fill it out on your notes. But what I want to point out is right here when it says f of x means function, and that's another way of writing y. And so we can keep that f of x, you can make it a g of x, a p of x, a b of x, a y of x, it doesn't matter what letter you want, okay? But something of x represents the function. So like on that first one, we added a number to f of x. So for an example, if I had the absolute value of x and I added 4, that would be an example of what that looked like. When you do that, you can do, when you add 4, the graph shifts up, whatever direction it is. So up, or not ever. I said that wrong. It shifts up whatever number has been added on. If you subtract a number at the end, then it shifts down whatever number has been added on. Now, as you can see, the first two look different than the second two because on the second two, the b is not outside the function, it's inside the actual parentheses. So this would work if it was inside the radical or inside the absolute value, like in this example where I say the absolute value of x plus 3. So 3 is in there, okay? And when it's in there, it's going to shift it left and right. That's a horizontal translation. Translation is just another word for moving. So this horizontal translation, when it happens, it's the opposite of what you think. So the up and down is the same, but the left and right is the opposite of what you think. So when it's plus 3, it's shifting it to the left. Excuse me. When it's a minus, it is shifting it to the right. Okay. The reflection over the x-axis is where we have an equation or a function and you put a negative in front of it, and that negative is going to flip the graph over. So if it was opening up, it is now going to be opening down, or vice versa. You're turning the graph upside down. Please note that with these reflections, any points that are originally graphed on the original one above the x-axis, when you do the reflection, they're now going to be graphed below, and vice versa. Points that are graphed below will then be graphed above. The last thing we have is a vertical stretch or shrink. And a vertical stretch is thinking about when you get a piece of gum or some kind of tacky candy and you pull it way far apart, it gets thinner and thinner. So when you stretch something out, it gets thinner, and that's the same thing that happens with a graph, and it's getting closer and closer to the y-axis and becoming more of a straight line. So when we have a number in front of it that's greater than 1, such as this example, 5 times the absolute value of x, it's going to make that graph thinner than the original parent function. Likewise, if you put a number that's in there between 0 and 1, and no, a negative doesn't work because it turns it over, it doesn't change the size. But if you put a number in there between 0 and 1, like 1/2 of the absolute value, that's going to shrink it down. So imagine this graph is in a press and you press down on it and it gets shoved together and it oozes out the side. It's getting wider and fatter, so it's shifting it down and making it fatter or wider. Okay, so let's talk about how we're going to do this. So on the first one, we need to figure out first what the parent function is. So we're going to look at this equation we've got and figure out which one of our 5 parent functions is it closest to. Well, the parent function that it's closest to is the absolute value of x1, the absolute value. Okay. If you know the points for the absolute value of x, you do not need to make a table. But in case you haven't memorized them yet, remember we always do -2, -1, 0, 1, and 2. And the absolute value of a number is always the positive, so this would be 2, 1, 0, 1, and 2. So the first step is to identify the parent function and then know what points you have to plot. Once you know those points, you can plot them on the graph, and this creates your parent function. All right, I should have said this earlier, but on these we want to have 2 colors, a pencil and a marker, or a pencil or colored pencil or something, so that or a different colored pen, so that you can see the difference between the 2 graphs. So this equation on number 1, g of x equals the absolute value of x plus 3, it started as the parent function of absolute value of x. However, a plus 3 got added, and when a number gets added or subtracted to the outside, it shifts it up and down, and it shifts it in the direction you think. So this one is going to go up 3. So with all these points, we are going to plot another point up 3 from it and create a second V that has, I'll graph that better, that has been shifted up 3 spaces. And there's my graph. Let's do this again on the second one. On the second one, if I look at that, the parent function that is most closely connected to this one would be the quadratic one. So the parent function, I'm abbreviating it PF, is the x squared. If you don't know it yet and need to make a table, remember we're still always plugging in the same points. When you square -2, you get 4. Square -1, you get 1. And there are all your points. So once I identify the parent function, then I'm going to make the table if I need it. If I don't need it, go straight to my graph and graph this quadratic function. Now remember, the quadratic is a parabola. That is your one that looks kind of like a U. So there's your parabola. Once you get that, then you have to figure out what this transformation is. When that positive or negative number is added or subtracted to the end, here it shifted it up, so now that it's a subtraction, it's going to shift it down. So we're going to regraph all of these points down 4 spaces. All right? Okay, these next 2 I've already filled out for you, but you can just look at it and pause the video and write it down. On the third one, our parent function that it's most closely related to is the cubic one, x cubed. So I figured out my points, I graphed it in green. That +2 added to the end showed me that the graph was going to be shifted up 2, so I redrew all the points, shifting them up 2. Okay, and now that I see it, one of my points is off, so I'm going to adjust it. Okay, on the fourth one, the parent function it most closely relates to is the linear one, y equals x. So I made the table for those. Remember, when y equals x, all the x's and y's match. So my blue graph is the original parent function. Then when I look at my new function, g of x, I can see that that graph has been shifted down 8 points. So I'm redoing my graph, shifting it down 8 points. Now, with the screen like this, you can see the difference between 3 and 4 and 5 and 6. Here, it is inside of the actual function. It's not on the outside. So when it's the inside, it's the horizontal translation, and it moves it left and right. Okay? So let's see if we can do that. So this parent function here is going to be the absolute value of x. We've already done that. That's the one that makes a V. We did that on number 1. If you're not sure which points I'm plotting, look at what you wrote down for number 1. Okay? When it's inside, it's going to shift it left and the opposite of what we think. So this is going to go right 7. So I'm going to go over 7 and regraph it. There's my absolute value. Okay, let's do the same thing on the next one. The next one, the parent function this most closely resembles is the quadratic one, x squared. Those points were already figured out on question number 2, so refer to that table if you need it. The quadratic one is the parabola. So let's graph our parabola. Remember, the parabola is the U. It's curved. Okay? Because this +5 is in the parentheses, it tells me that I'm going right and left, and when it's in the parentheses, it's the opposite of what I think. So this one is going to, started to write the wrong thing, left 5. So I'm going to start over 5 and then move all of those points over. Okay? All right, let's look at these next 2. Again, if this is going too fast, pause the video and get yourself caught up. On number 7, we have a radical that it most closely resembles. We haven't made a table yet in these notes, so I made the table. Remember, you cannot take the square root of a negative number, so that's why I started at 0. And I only picked the numbers 0, 1, 4, and 9 because 1, they fit on my graph, and 2, when I take the square root of them, they don't come out to be a decimal. They come out to be nice whole numbers, so you know how to work with them. Okay, so the blue graph is my parent function, and then because that +3 was inside of the radical, that tells me I'm going to have a horizontal translation, and those shifts are the opposite of which naturally you think they are. So going +3 is to the left 3. On number 8, we have a cubic. We've already used those points, so refer to number 3 in your notes and look at the cubic and see what those points are. But for your parent function, I graphed that in green, and then that -6 is inside the parentheses, so that's going to talk about shifting it left and right. It's the opposite of what you think, and because it's a -6, you're going to go to the right 6. All right, let's see what happens on number 9. Number 9, we have a negative absolute value. So before we figure out the translation or the transformation, know that the parent function is going to be the absolute value of x. We've done that before. That's the v. If you need the points, check them out on 1 and 5. All right, this negative right here is going to be a flip. Okay, it's going to turn it upside down, and it's going to flip it over the x-axis. So if you're not sure what it's going to look like at the end, literally take your paper and turn it upside down, and that's what this is going to look like. Any point that's plotted above the x-axis will now be below, and anything that's below will now be up. We're starting with all points that are up, so all these are going to go down. So 0, 0 is not going to change, but over 1 and now down 1, over 2 and now down 2, and my graph is now going to open down. Same thing on number 10. Number 10, the parent function is the square root. We've done this before, okay? If you look on number 7, you should be able to get all the points that you need if you need the points again. But there's my parent function. This over here, this negative, it's a reflection over the x. Okay? Or another way of saying it is we're flipping it upside down. Anything that was above the x-axis moves below. Anything that's below moves above. So I'm going to regraph my points going directly below the x-axis where they started. There's my graph. Okay, I need you to be able to do 1 through 10 well when time you take your test. The other ones, however, I'm going to give you more time because they're going to come up more in later chapters, but I do want you to see them and understand what they are. So let's first take a look at number 11. Number 11, the parent function is the linear one, just y equals x. That's a straight line. We've done this one before. Look at other examples for the points. Okay, but now we need to graph the, we need to do the 4x, 4 times that. Now we can't just move it right or left or up or down 4 because it doesn't say plus or minus. So instead of adding or subtracting 4, we're actually going to be multiplying by 4. And what we're multiplying by is actually the y. So if I look at this first point over here, 0, 0 doesn't do anything, but this first point over here, I found it by going over 1 and up 1. Well, whatever that up is, the up is going to be multiplied by this number. So I'm going to go over 1 and up 4. Then I went over 2, and the up is 2, so I have to multiply the up of 2 times 4. I went 1 up times 4, and I go 2 up times 4, which would be 8. Okay? Now I'm going to do the other thing, except I went down 1, so I'm going to double the down, quadruple the down and go down 4. I went down 2, I'm going to quadruple the down and go down 8. Now, when we have a number that's bigger than 1 in front of our function, it makes it skinnier and it gets it closer to the y-axis, which is what this one did. Okay, let me do one more. So the parent function is x squared. That is our parabola. So I'm going to make my parabola. Now, this 2 here is my multiplier. It what multiplies the up or down. So these 2 points right here, I went over 1 and up 1. So the up is 1, and I'm going to take it times the number in front, which is 2, So now I'm going to go over 1 and up 2. Then I went over 2 and up 4. So the up is 4, and I'm going to multiply it times this number in front, which is 2. 4 times 2 is 8. So it's going to go here. And now my graph, it's going to be skinnier because that number is greater than 1.